Welcome to Environment and Safety Management Institute Professional Training. Today we are looking at workplace hazards. Workplace hazards. What is a hazard? A hazard is anything that can cause harm. Anything that can cause harm is what? Is a hazard. Let's begin with machinery safety. Machinery hazards cause severe injuries including amputations, crushing injuries, and fatalities. Effective machinery guiding and safe work practices are very essential in any workplace that you find yourself in. Machinery hazards come in different types. There is what we call the point of operation. Okay, the area where work is performed, including cutting, shaping, boring, or forming. Most dangerous area requiring guarding, preventing access during operation, because the machinery in that place, all of them are sharp because they are the ones performing the operation. So that point of operation is what is a hazardous place. Then another type of machinery hazard that you have in your work environment is the power transmission, like gears, pulleys, belts, chain, shafts, coupling transmissions, okay, like motors to working points and all that. They must be guarded and prevent contact with it because they are very hazardous. Now the next one is rotating parts. Rotating parts. Any rotating component can catch your clothes, your hair, or your body parts and cause entanglement. So the people have to be protected from those rotating parts. Then another type of machinery hazard that you can have in the work environment is the nip points. Areas where rotating parts come together, such as belt and pulley or gear teeth, creating a crushing hazard. Those nip points should be protected because they are hazardous. Or another type of machinery hazard you can have in your workplace is flying particles, chips, sparks, okay, materials that are ejected during operations. They can create impact or eye hazard. So you definitely have to protect your eyes, protect your body from those materials. Machine guarding requirements. Now, gas must prevent access to hazardous areas. These gas must also withstand expected forces and conditions. They are not expected to create additional hazards. They are to allow safe maintenance when properly positioned, and then they are not to interfere with the proper machine operation. So when you are to fix your machine, you make sure that you fix gas around it, but the gas should not affect the operation of the machine. There are different types of gas that you have used in your workplace. There's what we call the fixed guards. Permanently attached guards that require tools for removal. They are the most reliable and they cannot be easily bypassed because they are fixed permanently in the workplace. Interlocked guards. These are guards that are connected directly to the machine so that the machine cannot operate when the guard is closed, and the machine stops immediately until the guard is open. You can see things like chain, whereby some people use a kind of a chain to lock the machine. You can't be able to move it until that guard is removed. Then you have adjustable guards that can be adjusted for different operations, but they must be manually repositioned. Let's talk about safe operating procedures, SOP. Never operate machinery without proper training and authorization. You have to conduct a pre-use inspection to verify the gas are in place and they are functioning before you do what? You operate any machine. Never bypass, remove, or defeat gas or safety devices. Always keep the work area clean. Prevent slip hazards near the machinery. The essence is that if there are slip hazards near the machinery, it is possible that immediately somebody trips and slips on it, the person will be injured by the machinery. Make sure you wear your appropriate clothing so that you avoid loose leaves. Because if you have loose leaves while operating your machine, then definitely one of the loose leaves will easily be entangled with the machine, and the next thing is what? Is an incident. Also make sure that you keep your jewelries at arm's length with the machine. You cannot be operating the machine and then you put on long jewelries. They will definitely affect you if they get entangled with the machine. Not only jewelries, dangling objects entirely. There are some people, especially ladies, that you see them carrying very long hair. Make sure that you cover the hair properly before you start work near a machine. Secure those long hairs. Cover them. Report defective equipment immediately and tag out until it is repaired. All these are what? Self-operating procedures. SOP. Logout / tagout, what we call LOTO or LOTO. When we are talking about logout and tagout, it prevents unexpected machine start during maintenance or servicing or repair. What do you mean by a logout? A logout is a situation whereby you cut off a supply of energy into a particular area during operation. Tagout is when you bring a tag and put it on the area that has been locked out to notify anybody or any intruder that there is work ongoing and the machine should not be what? Should not be energized. When do you require a logout and tagout? LOTO is mandatory when servicing or maintaining machines where unexpected energization, startup, or release of stored energy could cause what? Injury. These include electrical work, mechanical repairs, equipment cleaning, inside gas, junk cleaning, and any work exposing employees to hazard from energy sources. What are those energy sources that require this control? Number one, electrical energy. Power supply including high voltage, low voltage, and control circuits. Okay, they have to be what? They have to be locked out. Mechanical energy. Stored energy in springs, elevated components, rotating flywheels, or pressurized systems. They have to be locked out. Hydraulic energy. Pressured fluid systems or pneumatic energy. Okay, compressed air or compressed gases, or chemical energy. Processed fluids, chemicals in piping or equipment. Thermal energy, steam, hot surfaces, cryogenic materials. These things has to be what? Has to be tagged out, locked out while you are what? You are operating. Lockout and tag out procedures. The first thing is the preparation. You identify all the energy sources that require control, you notify affected employees that the logout and tagout will be performed. Then you shut down. You shut down equipment using the normal stopping procedure. Then you isolate the area, okay? You operate the switches, the valves, other devices. You isolate the equipment from the energy sources completely. Don't rely solely on one control circuit or switch. No, make sure you isolate everything. Then the logout and what? The lockout and the tagout. You apply your logout devices like locks, chains, blocking devices, and then you put the tags to isolate those devices. Each authorized employee applies their personal lock so that the equipment cannot be re-energized until they that lock it out come to what? To unlock it. Stored energy release. Stored energy what? Release. You release, you disconnect, you restrain. Otherwise, you neutralize the stored energy, including blocking elevated components, bleeding hydraulic or pneumatic systems, discharging capacitors, and allowing hot equipment to cool before the operation is done. Then verification. After you have done the logout and tagout, you verify the isolation by attempting to start the equipment using the normal controls. Then you return the controls to off position after the verification. Then you test with meters to know that, okay, truly everything is what? Is completely locked out and what? Tagged out. Then you perform your work by that time. With this verification complete, the authorized employees may perform the necessary work. And after the work, you now what? Restore the energy. When the work is completed, you remove the tools, the materials, you ensure that all the personnel are clear, you remove the lotto devices. It is only the person that applied the logout and tagout that you remove those devices. Then you notify the affected employees that the energy is going to be what? Restored. What are the lockout devices that you are going to use? You use standardized lockout devices, including padlocks that are assigned to individual employees, or hubs allowing multiple locks, or circuit breaker lockouts, or valve lockouts, or plug lockouts, or cable lockouts. These devices must be durable, standardized by color and format, substantial enough to prevent removal without excessive force, and identifiable, indicating the employee who applied them. Then the tags. The tags are worn against re-energizing the equipment and identify who applied the logout. Tags must state "do not start." A tag must state what? Do not start, do not open, do not close, or similar warnings. It should include the name of the employee applying the tag. It should include the date and electrical safety. Electrical hazards cause severe injuries, including electrocution, burns, force from shock reactions, and fires. What are the electrical hazards that we have? These electrical hazards include things like shock, which is the electric current that passes through the body, potentially causing heart fibrillation, respiratory paralysis, burns, or death. Severity of electric shock depends on the current magnitude, the path through which it follows through the body, the duration of contact with the body, and the body resistance. Another electrical hazard is arc flash. This is the explosive release of energy from electrical arc, causing severe burns, pressure waves, molten metal projection, and intense light. Arc flash injuries are often fatal or permanently disabling. Then another one is arc blast. This is a pressure wave from arc flash. It causes hearing damage, lung damage, force, and blunt trauma. Then another electrical hazard is burns. Direct contact with energized conductors or arc flash can cause severe thermal burns. Another electrical hazard is fire. Electrical force ignites combustible materials, and this causes fire. What are those electrical safety work practices that we should look at it? Now, the first work practice in electrical safety is what we can classify as qualified versus unqualified persons. Only qualified persons should be allowed to work on energized electrical equipment. The qualified persons are those people who have training and knowledge of electrical systems and electrical hazards and are authorized to work on specific equipment. Another issue of electrical workplace safety is the issue of working de-energized. Now, you establish electrical safe work condition through lockout and tagout whenever possible, and this is the safest approach towards working in electrical places. Now, apart from de-energizing the workplace, another thing is energizing the workplace. Permitted only when the energizing creates greater hazards or it is infeasible. Now, there are some situations whereby you cannot de-energize the system. So when you cannot de-energize the system, you can still work when the system is energized. But remember, at this point in time, you have to have your full personal protective equipment. It has to be under strict guidance. This requires detailed planning, shock and arc flash hazard analysis, appropriate personal protective equipment, and strict adherence to safe work practices. Safe distance. This is another electrical safety work practice. Maintain appropriate approach distances from energized conductors based on voltage levels. Unqualified persons must maintain limited approach distances. The qualified persons may enter the restricted approach distance only with appropriate training and protection. So let's look at the personal protective equipment for electrical safety. Personal protective equipment for electrical safety. The first thing is insulated tools. You use properly rated insulated hand tools and equipment for work that is near energized circuits. Rubber insulating glues, voltage rated glues with leather protectors for work on a near energized conductors to be used. Then arc rated clothing, flame resistant shirts, pants, overalls, hoods, or suits provide protection against arc flash thermal energy based on hazard analysis. Then you talk of face shields. Arc rated face protection over safety glasses are preferable. Electrical hazard footwear. This will provide you protection against step and touch potentials. Facility electrical safety. You ensure that electrical equipment is properly installed by qualified electricians and meet applicable codes. You maintain equipment in safe condition through preventive maintenance programs. You keep the electrical panels accessible with 36 inches clearance. You label all your panels and your circuits clearly. Never use damaged cores or plugs or tools. Use ground fault circuit interceptors for protectable tools and temporal power. So this has to do with making sure that you train your employees to recognize the electrical hazards and report deficiencies immediately when they are done. Let's talk of confined space entry. Confined spaces are areas that are not designated for continuous occupancy, with limited entry or exit and potential for hazardous atmosphere or other serious hazards. Now, when we talk about confined spaces, this includes things like tanks, vessels, silos, pits, manholes, sewers, tunnels, underground vaults, pipelines, and bins. What are the hazards in a confined space? Now, atmospheric hazards. What are the hazards in a confined space? You have different forms of hazards in a confined space. Let's begin to look at them one by one. The first one is atmospheric hazards. Number one atmospheric hazard is oxygen deficiency. Now, whenever the oxygen is below 19.5% of the constituents of the atmosphere in that place, it's hazardous from displacement, from consumption or absorption. Or when oxygen is more above 23.5%, it begins to increase fire risk. Flammable atmospheres from vapors, gases or dust, or toxic gases or vapor can also constitute atmospheric hazard. Airborne contaminants that exceed the exposure limit can also constitute atmospheric hazards. Then you talk of physical hazards. Physical hazards in the confined space include things like engulfment in liquids, grains, or flowing materials. Configuration conducive to entrapment or asphyxiation is also a hazard. Then you also have things like mechanical equipment, electrical hazards, extreme temperatures when the temperature is either too high or too low. And then you also have permit related confined spaces. Okay, these are spaces with one or more characteristics that require formal entry permits and additional controls. So what are those characteristics in the confined space that require specific entry permission? Now, when a confined space contains or have potential to contain a hazardous atmosphere, another condition is when a confined space contains materials that could engulf an entrant. Another one is when a confined space has internal configuration that could trap or asphyxiate an entrant, or sometimes it contains any other recognized serious safety or health hazards. So what are those entry procedures that you need to have in a confined space? Now let's look at pre-entry planning. You identify the confined space and classify it as permit related or non-permit related. Then you develop your written entry procedures. Okay, you now assemble your entry team with defined roles. Who is going to be the entrant, who is going to be the attendant, who is going to be the supervisor. All these roles have their specific duties. So you identify the hazards and you determine the type of control that will be used on these hazards. Now let's talk about the entry permit. Entry permit. Now you issue a written permit authorizing entry and specifying space identification, entry purpose and duration. Authorize entrance and attendance, entry supervisor, hazards and controls, and atmospheric testing results. You rescue services available, communicate procedures and equipment that are required. Then apart from the entry permit, another thing is atmospheric testing. Okay, you test the atmosphere before entry and continuously monitor during entry. What are the things you are going to monitor? One, oxygen level. Remember, we said that the oxygen has to be between 19.5 to 23.5%. So you keep on monitoring it. Once it's out of this threshold, it becomes dangerous. You also monitor the flammability of the confined space. It must be below 10% of the lower explosive limit of that particular environment. Then you also monitor the toxic gases, the vapors. Okay, they must be below the permissible exposure limit. You must calibrate your instrument regularly and test from the outside and then the inside before you allow anybody to enter the confined space. Confined space also needs ventilation. So you provide continuous forced air ventilation when feasible to maintain an acceptable atmospheric condition. Make sure that you use non-sparking blowers and ensure ventilation does not create hazards while the person is inside the confined space. Now let's look at the entry team. I told you that you can either be the entrant, the attendant, or the supervisor. So let's look at their roles. Now the entrant, they are the trained workers that are authorized to enter the confined space. They must recognize the hazards, they must use the required equipment properly, they must maintain communication with the attendant and exit immediately if the hazard is recognized or when the attendant ordered that they should exit the confined space. Let's look at the attendant. The attendant remains outside the confined space, monitoring the entrance, maintaining communication, and preventing unauthorized entry. He also summons rescue if there is need, and he orders evacuation if necessary. The attendant never enters the confined space, he remains outside. Now, what about the entry supervisor? He ensures that proper procedures are followed, permits are completed accurately, conditions remain acceptable, and cancelling permits when entry operations are complete. Rescue planning. Establish rescue procedures before the entry into the confined space is done. Options include self-rescue by the entrant, retrieval systems where you use harnesses and the retrieval lines for quick extraction of the attendant, on-site rescue team, or emergency services. Never attempt untrained rescue because most confined space fatalities involve the would-be rescuers. So if you have not been trained in rescue, never attempt rescue. Let's look at fall protection. Falls from elevation are leading causes of workplace fatalities and serious injuries. So what are the fall hazards? 1. Walking at height above 4 feet or 6 feet. 4 feet in terms of general industry and 6 feet in terms of construction will create fall hazards. Specific situations include elevated work platforms, roofs, scaffolds, ladders, open-sided floors or platforms, holes or openings, and elevated equipment. What are the fall protection methods that we have? 1. You have guardrail systems. Rail systems along open edges preventing falls through passive protection requiring no worker action. Top rails at 42 inches, mid rails, and 2 bolts for complete systems. Now, when we are talking about fall protection, another thing that should come to our mind is the issue of safety net system. These are nets that are installed below work areas that can catch a falling worker. This nest must be within 30 feet of work level and extend adequately beyond the edges of the work space. We also have what we call the personal fall arrest systems. These are equipment that are worn by workers that arrest falls. Components of them include full body harness, connecting devices like lanyard or self-retracting line, and they are built on an anchorage point. Now the system must limit maximum arrest force to 1,800 pounds and the maximum arrest distance based on configuration. We also have what we call the fall restraint systems. These are systems that prevent workers from reaching the fall hazards by limiting their movement. They allow the working at height without potential of falling. Then we have positioning systems. These are devices that support workers on elevated surfaces, allowing hands-free work while preventing falls. Warning line systems, barriers warning workers. They are approaching unprotected edges. They should use low slope roofs and additional protection for workers beyond the lines. Ladder safety. The first thing is the selection of a ladder. Use proper ladder type and height for your tasks. The ladder should have an extension that is about 3 feet above the landing point. Step ladders must be fully opened. How do you set up your ladder? You place on a firm level surface. Set an angle of extension of the ladder at 75 degrees. That is 1 foot out of every 4 feet up. So you secure a top or have a stabilizer setup. How to use the ladder? You face the ladder when ascending or descending. You don't back the ladder. You always face the ladder when you are climbing it, going up or coming down. You maintain 3 points of contact. Never stand on top the 2 steps of the ladders. No, the last 2 steps, don't stand on them. Your last point on the ladder should be the third point. Okay, don't overreach or move the ladder instead. Okay, if you are to work on the ladder, don't overreach. Instead, move the ladder closer. Don't carry materials that prevent secure grip while you are on the ladder. Anything, that's the reason why you need to wear an overall that have pockets, so that anything that you are to use, you put it inside a pocket, and while you are climbing and coming down, so that you have a firm grip of the ladder while moving.